Okay, so some people left early today, and some people might have been confused because we went a little bit fast. So let's talk about negative exponents. So before we can talk about negative exponents, we have to understand what exponents are. So if we take something like 2 to the fourth power. So this is broken up into two parts, which is the base and the exponent. And this whole thing together call a power. Okay? What this is just 2 times itself this many times, 4 times 2 times 2 times 2 times 2, which is 16. Okay, and we did this in 7th grade, hopefully. So it shouldn't be too bad. So what we're adding this here is how to deal with negative exponents. So let's make that transition here. Okay, so we draw ourselves a table. Okay. And on one side we put our powers, and on the other side we put their value. Okay, and if we take something with a nice base like 10, say 10 to the third power, it's equal to 1,000. Okay, leave some space here. We'll see in a minute. If we go down the list, 10 to the second power, 10 times 10, okay, that's just 100, right? Okay, if we keep going, if we go 10 to the first power, which is just 10, right? 10 times itself one time is just 10. And we see a little pattern here. It's every time we take away a times 10 here, our decimal moves over one place. It gets 10 times smaller because it's one less 10. But if we keep going to numbers we haven't seen before, like 10 to the 0 power, this pattern continues. So 10 to the 0 power is just 1. It's a little bit tricky to think of if you haven't seen it before, but key here is that any number to the 0 power, 0 with, is equal to 1. 1. Except for 0. 0 is its own thing. We don't worry too much about that. Okay? But now we can keep this pattern going. If I said 10 to the negative first power, so we just keep decreasing 1, 3, 2, 1, 0, negative 1, and we just keep moving the decimal. So now we're going to have, I'll do this. Kind of mess this up, I guess. Well, let's keep the 1 there. That'll work. We'll have 0.1, okay? Or this would be, we wanted to add another column here. This will help us out in a second. This is 1/10, right? Call this fraction. Move these cool notes out of the way. Right? And we can keep going. So 10 to the negative second power would be 0.01. Okay? And that would be 1/100th. Why am I drawing so small? Anyway, 100th. There it is. We kept going. One more. Last one. 10 to the negative third power would be 0.001, or 1/1000. Okay? So now hopefully, see a couple patterns there. 1, the decimal keeps moving. 2, once we get into the negatives, we see this fraction, this denominator here, is very similar to our previous value in our positive exponents. Okay? Because that's the connection. These two are very much related, and that negative exponents are just fractional values of positive exponents. So let's take a look at a couple more examples like that. So I didn't bring any exact problems. We're just going to try to remember. We'll make stuff up. So if we say 4 to the negative second power, what would that be the same as? Okay, so all we do is the whole thing. Anytime we have a negative power, make a fraction. So there's nothing else here. We put 1 on top. Take the same base. Base doesn't change. And then we flip the sign of our power, or of our exponent. So negative 2 will become positive 2. And that's it. And we could evaluate this if we wanted to. This would be 1 over 4 times 4 is 16. And if you don't believe me, you can put it in a calculator. Okay, but that's it. All it is, you take your exponent, make it positive, you put it in the denominator of your fraction, right? You don't even need a number for this. If we said w to the negative third power, that's just equal to 1 over w to the third power. And that's all it is. Okay? We can also go the opposite direction with this. If it were to give you a fraction, if we said 1 over 8 to the fourth power, how could we rewrite this without a fraction? Well, we said here we had a fraction because we had a negative exponent over here. So if we have 8 to the positive fourth in the denominator, we can rewrite that as 8 to the negative fourth, and that's it. These two are equivalent expressions. And if you want to put these numbers in a calculator, you will see that they are indeed the same exact thing. Okay? Something we left off on some of the classes that we didn't get to talk to, and I said I would go over it, is what to do if you had a problem like this here. Ugh, let me just erase this. I don't like this number anymore. Where did my eraser go? Okay. So let's not even use 2. Let's call this uh, let's call this 6. Okay. So you have 3 to the 6 times 3 to the negative fourth. So if you have the same base, if it's the same base, and you see they're being multiplied, so multiplication, you're always going to add the exponents. Okay. So now this involves adding and subtracting integers. So if you forgot how to do this, you probably want to grab a calculator or remind yourself how to do it, because otherwise you're going to get these wrong. But 6 plus negative 4 is equal to 2. Okay. So 3 to the 6 times 3 to the negative fourth is just equal to 3 to the second power. And that's it. That's all this involves. Okay? And again, you don't need numbers for this. If we said s to the negative fifth times s to the negative second. Okay? Since they're being multiplied together, we just add our two exponents together. So negative 5 and negative 2 makes negative 7, right? And if we don't want a negative exponent, because negative exponents are generally frowned upon, we can rewrite this as 1 over s to the positive 7. And that's that. Piece of cake, right? So that's multiplication, but what about if we have to divide? So let's say we have the number 12 to the third power divided by 12 to the 7th power. Why not? Okay, it's a little bit different. If you're dividing, instead of adding your exponents, you're going to subtract the exponents. All right. So in this case, we're going to say, what is 3 minus 7? So 3 minus 7 is going to give us 12 to the negative 4. And for all these, notice it always has to reiterate the same base, both numbers. This will not work if the bases aren't the same. And since they're the same, it's going to remain the same in your answer. Okay? Never mess with the bases. The bases are fine. The only thing we deal with are exponents. Okay? So 12 to the negative fourth, which we can then rewrite, because we don't want our negative exponents, as 1 over 12 to the positive fourth. That's it. That's all you gotta do. All right? Let's practice a little bit. Come back with questions tomorrow. Okay, like, comment, and subscribe.